more. And then we have the second paper, and the second paper entitled with hierarchical linear mixed model, and which is we emphasize or we assess to poverty data in Indonesia. So I will told that from a review paper we have we can extend the former paper into the new two papers. It's opportunity for us and for Bapak Ibu semuanya. I will try to introduce the background of the paper. A linear model, and we use the linear model with Gaussian random component, which is presume that the error component is estimation of the expectancy of the error is 0 and the variance error is sigma quadrat E. And the variance structure is always presumed to be constant variant and uncorrelated, maybe in ordinary way. And one of research that developmental research evolved in wide variety in scientific fields. And data is always same like longitudinal data, which is described a response variable with repeatedly repeated measurement for each in analysis unit and time as the repeated factor. Linear mixed model is one of the statistic procedure that provide a flexible approach in statistical analysis, especially in longitudinal data, which is there is a correlated unit or correlated value unit between them. One of the analysis of longitudinal data is growth curve. Growth curve will represent of two-level hierarchical linear model, in which there are content of two variation, which are within subject variation that define the first level, and between subject variation defined at second level. In the first level, or we call it within group or within subject model, is defined the observation by linear regression as modeling the growth pattern for each individual as function of the set of the growth parameters. It's expressed in equation 1. That there is a function of the growth parameter beta E, and then the model growth pattern of each individual is set as a function of the set growth parameter, and then response variable are modeled as a function of time and in the subject component of error. This is in the level 1, and the level 2 and the second level or between group model. We have the growth parameter is modeled as a function population mean and the subject deviation of each parameter. The complexity of the model is increases when the covariance that describe the variation between growth parameter is included in the model, since there are correlated value between the subject. This is the expression this of model in level 1 and the model in the level 2 in equation 2. And the integration of the two level in equation 1 from equation 1 and equation 2, we had the complete general linear mixed model. It's only general, not generalized. General linear mixed model. And the formula is expressed in equation 3, where the error model in the level 1 is distributed normally with expectation of mean is 0 and the variant covariant is sigma quadrat E, and error level 2, which is noted by UE, is distributed normally with expectation of mean is 0 and the metric variant covariant is described as G. And by this complete model, we have the variant of Y to be uh, variant from the that expressed in Formula 4, and in the model, the variant of uh, growth differences from the subject are combining from the variant of the level 2 and the variant of the model 1 or level 1, which is in this paper. We will have more extension, or we have more interest in the variant of the subject, which is uh, described by the sigma quadrat E. This is the notation of the variant of from the response variable. From this equation 4, variant of error is assumed constant variant and uncorrelated by time, though usually it will be violated since the object or the subject in the longitudinal data will be correlated. And we said before that the linear mixed model have an excellent way to estimate the variant covariant with uh, other model not in uncorrelated on the constant variant over time. The advantage of the model of the variant covariant is the regression parameter can be estimated more accurately. This is some structure of the variant covariance model. One of the linear mixed model advantage is we can model the variant covariant matrix structure from the data that we denote with matrix R or sigma quadrat E, and it can give us more improvement in estimation accuracy, so that the power from detection treatment effect can be more accurately. And there are many type of R structure. First is unstructured model, and in unstructured model we have more so many parameter to estimate, and but every parameter in this metric has unique value, or with it will have unique correlation pattern between observation. Uh, the other model is compound symmetry. Covariant compound symmetry structure, we will have a value 1 in the main diagonal. It means that there are correlation of the unit from the longitudinal data itself at 1, and then the correlation of each from the subject is rho, and then it's constant. There's a constant component covariant from uh, unit E and the unit J and others. And then we have first order autoregressive covariant matrix. In the first order autoregressive, we have sigma quadrat multiplied by matrix with diagonal. Main diagonal is 1, and then the others is decrease exponentially with rho multiply. We can say that the correlation between subject E and the J is rho, and then E and the J plus 1 is rho square, and then E and the J plus 2 is rho power 3, and then decrease exponentially with uh, value of the degradation is rho. And then the generalization of the compound symmetry variant covariant structure and the first order autoregressive covariant structure is symmetric heterogeneous compound or GSH, and then for the R1 generalization is ARH1. The different component symmetry and from the heterogeneous component symmetry is the value from the main diagonal, that the main diagonal of heterogeneous component symmetry is sigma quadrat A for the covariant from the error in the subject 1, and sigma square 2 is the variant from the subject 2. And the heterogeneous first order autoregressive, the difference from the AR1 is the main diagonal is different, and then the covariant is multiply row by the sigma quadrat 1 and the sigma quadrat T as the covariant from the subject 1 and the subject 2. Now, from the variant covariant structure, we can have a conclusion that the structure model from the R1, GS1, R1, and GHS1 have the constant parameter. Then this can be more efficient and powerful from the R structure in detecting treatment effects. In Arno paper or the former paper, they have the children with repeatedly measure from 5-year cohort. They will measure in the first year to the 5th year, and then we use the data by simulate, by generate. Since we don't have the real data, then we generate the data from the paper, and then we simulate the data. We in this paper, the motivation is we want to know what the best covariant matrix structure to model the growth development data. So we need to generate the data. The aim of the study is to examine the change in the children weight over time as a consequence of the method of feeding that we with the best covariant matrix. With the feeding groups are spirit with the best feed group have 56 participants, and bottle feed group has 84 participants. And from the former paper, Arno paper, we just have that information that the bottle feed group has mean in each year. In first year, the bottle group mean is 10 kilogram. Until the 5th year, the bottle feed group have mean average is 18.5 kilogram. And the breastfeed group in the first year, we have average weight from the baby is 9.8. Until the 5th year, it is 70.4. Then from the information, we try to generate the data, and the process, we use the mixed procedure in SAS system, and in SAS system we also model the R structure with mixed procedure. And we have do 100 simulation from its generated data, and from the 100 simulation, we have the profile of children's weight data or the children's growth data, which are in the best fit group. We have the data is profile is show in the graphic that from the two group, the data show that the weight increase. The weight is increased during the first year of life, and until 5 years it increased. It's not surprisingly, but if we can more check it, that the data weights indicate that the variance from the breastfeed or the bottle feed is getting higher over time. The variant of the width is increased higher over time from the first year to the fifth year. And the both group shows that the larger variant in width, along with children age, larger variant occurs in the fifth year's observation. In the first year of fifth year observation, the variant is more greater. I think it's a show for us that the variant of the data is not constant. It's not what normally we use the least square model that the variant is presumed with constant variant. I think it's uh, suitable if we try to examine which structure is the best for modeling this data. So we need to know where the best structure from the data, and the data indicate that children variant increase in every years. Thus, modeling our structure with constant variance models such as AR1 and compound symmetry are no longer relevant. In Arno paper, the growth model with the uh, real data, it model with compound symmetry and AR1 and unstructured model. But in the first paper, we no longer use the AR1 and JS1 model since the variant is not longer relevant. That that we know that from the graphic the variant is higher or it's more bigger in the fifth years. So that non-constant variant models such as unstructured, AROH1, and compound symmetry heterogeneous one could be the alternative. Compound symmetry, heterogeneous compound symmetry and heterogeneous first order autoregressive, we will have 5 unique variant in each time and 1 correlation parameter. And then in uh, heterogeneous compound symmetry, it present correlation over time, while in heterogeneous autoregressive, first order autoregressive will present exponentially decreasing correlation over time. But in unstructured model, we will require 15 unit parameter to describe the characteristic children growth. So from this we can have a little conclusion that in unstructured covariant model we will have more many parameters to describe. Yes, I think we will use the more efficient to make the estimation more efficient. This is the result. The estimated R structure from the heterogeneous compound symmetry and heterogeneous autoregressive, first order autoregressive. Uh, this is the estimated R structure, which in the first line, it shows the correlation of the group, is the correlation of the each group from the H1 first years until fifth years. And the second line, we have the variant covariant value from the growth weight, children growth weight. From the heterogeneous compound symmetry, will have built value of the variant covariant from the first eight and the second eight is 1.2, and the correlation is 0.7 on 70%. Then we have 5 unique variant and 1 correlation parameter. In order to obtain the best fitted R structure to generalize the result of the simulation study, we generate children with data with 100 questions with from unstructured covariant model until heterogeneous first first order autoregressive. And each representation, we model the matrix variant covariant R using different type with non-constant variance model, like the unstructured model, the heterogeneous compound symmetry, and heterogeneous uh, first order autoregressive. With the indices criteria is minus 2 log likelihood, AIC and BIC. Based on this criteria, we rank the model which produce smaller value from the fit indices is the best model, is the better fit for the art structure. And this is the result, the rank of it statistic and the model likelihood ratio test. By the table, we can have an uh, conclusion that the heterogeneous first order autoregressive has the little value in the rank than the compound symmetry heterogeneous. But the unstructured variant covariant model is the smaller rank in the criteria. But it's not surprisingly results in the unstructured covariant model is must be have model, but it more have many variants, many parameter to estimate. By this result, we can conclude that the heterogeneous first autoregressive could be one of its alternative structure variant covariant model. This is the p-value of the estimate parameter from the variant covariant structure heterogeneous first order autoregressive and the heterogeneous compound symmetry. Uh, this is the p-value of the feeding component feeding parameter. From the p-value, represent the significant meaning of the effect of treatment. That the bottle feeding uh, is have the effect of the weight from the baby. In children with data, we have fit, age, and the interaction fit and age as the fixed effect. Since feeding method is the constant covariate in children growth with differences, therefore it's important to examine the effect. Uh, Beside that, the table so also summarize that for any generated R structure, AR1 gives small p-value for fit effect rather than the other model. Uh, since the linear mixed model will have more accurately in estimate parameter, we can conclude that the AR heterogeneous one is have the smallest p-value rather than the other model. From the first paper, we have the conclusion that based on the simulation study, the best fit structure metric for every generated data is the original. I mean, if we generate the data from the unstructured covariant model, so the best fit uh, model for the variant covariant is also unstructured. If we generate the data from the compound symmetry variant covariant structure, so the model, the best fit is also compound symmetry. And based on p-value, uh, heterogeneous first order autoregressive covariance variant matrix also give more accurate estimation on the regression parameter. So in the longitudinal data with linear mixed model, heterogeneous first order autoregressive can be an alternative beside the unstructured variant covariant model. This is the conclusion from the simulation study. And for the application, we assess the poverty data, and we have the second paper. In the second paper, we assess the linear mixed model, which it has many names. It other can call hierarchical linear mixed model, other call with linear mixed model, other call marginal linear mixed model, or variant covariant model. There's many names for this model. And for the second paper, we name the other name. We call with the other name. It will give more difference that can be extension. I mean, we name this model with hierarchical linear mixed model and assess for the poverty data. So we name it with hierarchical linear mixed model for poverty analysis in Indonesia. Why poverty? I think Bapak Ibu has more experiences in poverty than me, I think. And the first of SDGs goals is eradicating the poverty in all forms, and it's the great challenge for us and for all the united. And it's a big challenge for developing countries like us to reduce poverty. Such great challenge illustrate diversity of religions, type, and diversity of natural resources in each province. And one of the issues in the development economic that the interregional development gap, among others, is one of the cause of the poverty. So the motivation of the paper is to define the variation, the correlation, and individual province effect of poverty in each over time. And the second motivation is to emphasize the region effect in eradicating poverty in Indonesia. The choice of variant covariant structure can be made graphically that represent the information of the data. I mean that the choice of the variant structure, we have to elaborate the data. We have to explore the data first, and then we can give estimate parameter accurately as efficient as possible. So that by the elaborate data in this paper, we applied the compound symmetry covariance structure, then the first order autoregressive, and then the generalization of compound symmetry, heterogeneous compound symmetry, and the generalization of the first order autoregressive, heterogeneous autoregressive, and we adding one structure that's autoregressive moving average with the parameter is for the moving average also one. The parameter for the autoregressive in the first order. I mean, the adding, the little edit, like the adding of the covariance structure, like one ARMA, it could be one paper. It's not, no, no need to hard work. I mean, uh, why we add the four, we use the five covariance structure, we have justification that the structure have more efficient in number of parameters, and from the simulation study, The heterogeneous autoregressive, first order autoregressive also can be alternative. So we put the heterogeneous first order autoregressive as the alternative. From the variant covariance structure of autoregressive, first order autoregressive and the moving average uh, with parameter 1 is this also have decreasing exponentially with additional parameter is gamma as moving average component, and it satisfies that the constraint is um, value of the constant gamma is less than 1, and the rho is autoregressive parameter. Indonesian poverty data, we use the poverty of each province, that the data from the 2007 until the 2016, which defined by its region. Western Indonesian region consists of 70 provinces, and Eastern Indonesian region also consists of 17 provinces. Uh, I'm sorry, this is less of the explanation. There is one province in Eastern Indonesian region that only available the data in 2015 and 2016. We will try to explain, or we try to show that the analysis from the longitudinal data is a little different from the time series data, so that we can have a little time series or a little point data in time, then the time series, since the time series have two more point time, and we can also use this model in unbalanced data, uh, like this paper. In this paper, we use the fixed factor is the dividing from the region, and like the Indonesian Western and the Eastern, and the random factor is province. The profile from the poverty data is shown in the graphic, that the West Indonesian region has uh, uh, decreasing trend, also in East Indonesian region. But the trend is not monoton. It can be fluctuative. Uh, the poverty trend is negative, but the variance is not constant. The variance from the poverty in province in the Western Indonesia is less value than the variance from the poverty in the province in Eastern Indonesia. This is the variance covariance value and the correlation estimate from 5 different covariance structure, which in the compound symmetry and first order autoregressive covariant matrix, we only have 2 parameter. The parameter is variant 52.46 or 50, and the row is 0.9 or 90%. I mean that correlation from the poverty value in each province by time is uh, 90%. It's not independent, it's dependent. So we have to make some uh, uh, perbaikan adjustment from our from myself. I think is this, that the poverty in its time are independent. And from the ARMA, we have three parameters that defined by the variance is 56.61, and the covariance is also in 99%. And the generation of compound symmetry and first order autoregressive, we will have 11 parameter for heterogeneous compound symmetries and also for heterogeneous first autoregressive, which are the variant and covariant for each time is decrease, and then the rho is in heterogeneous compound symmetry is constant, but in the heterogeneous first autoregressive is also decreased exponentially as rho. This is the fit statistic from the covariance structure, and from the fit statistic you can conclude that unstructured type always best in presenting the result, since each of the parameter in the variant covariance structure is unique. But from the three criteria fit statistic index, we also get a conclusion that the heterogeneous first order autoregressive also can be the alternative. This is the estimate value from the parameter regression, region, years, and the interaction from the region and year. Uh, the best model that we choose is the variant covariance structure of heterogeneous autoregressive, first order autoregressive. From this model, we have concluded that the region have the PPL value is 0.2. So we can state that region do not impact the eradicating of poverty in Indonesia. Uh, we mean that the dividing uh, the region by western or eastern is no longer uh, suitable. We means that the Indonesian development is equal, so the poverty cannot. Uh, so the eradicating of poverty is not depend on the region. That's the conclusion for our second paper. In the end of the uh, session, this is discussion from the two paper of uh, us, where this paper the geometric, the metric of the fixed effect is presumed to be zero. Uh, it's still more can be more extension paper, whereas it also can be model, like the variant covariance structure of the random effect R metric. And this paper do not include covariant variable. Then this the open result or open uh, problem. Uh, I think that all of you, Bapak Ibu, also can adding the covariant variable from this model. It can be extended. I think my explanation is enough. Uh, Maybe we can discuss for more extension. Thank you.
Thank you very much, Bu Novi, for I think this is full of statistical method that I don't understand. Really, I don't understand what this even What is the longitudinal data? I don't understand. Okay. Uh, in the session of the presentation, I heard some little discussion from Pak Pras and Bu Moni and from Putio and Pak Sukim. I think they have already prepared the questions to Bu Novi. So I think let's the audience to ask or to give some suggestion uh, for the maybe the next paper, right? Okay, thank you.
Thank you for the opportunity. First of all, congratulations to Miss Novi because you can make one paper into more than one paper by yourself on your name. The one thing that captured in my attention in this paper is when you say that the aim of this paper is looking for the best covariant matrix. I already have discussed with Pak Pras what is the criteria for the best covariant matrix and how the mixed model how mixed model can be explained in this paper. Thank you.
The question, the first question is, what is the criteria, the best structure covariant? Yeah. The I think we should from the second question first. I will ask the second question. Does the mixed model are expressed in the formula 3 that in response are function from the parameter from the covariate that we the fixed covariate and the random covariate, and from the two covariate, the fixed and the random covariate, we will have the variant covariant structure. So that the variant covariant structure in the mixed model are consist of the variant covariant structure error in uh, within subject. If we have the growth with data, which are the variant covariant in each baby in every group. And then in the level 2, we have the matrix variant covariant each group, like the bottle group and the feed and the butterfoot, breastfoot and the breast milk and the butterfeed. That we in this paper we just concern in the matrix in the variant covariant structure of error within subject. Since within subject we have to we are realized that there are correlated value from the subject since the subject is measured repeatedly from the first years, second years, third years until the fifth years. So we can no longer assume that the variance from the within subject is constant. And then we try to examine which the best variant covariant matrix that more suitable from the longitudinal data or repeatedly measurement data. Nah, the criteria to know which one is the more suitable, we use the fit criteria index such as mean 2 of log likelihood, and AIC and BIC. And we also can use the SBC, but in the paper we do not the SBC. We just use the 3 fit indices.
Yeah, thank you for your explanation, but it led me to another another question because not a question actually. This is I need confirmation. So if you look for the best covariant matrix in AAC and BIC, then it means that we make the covariance first, then we reverse the process to get the estimate parameters. Then we have the AIC and BIC. Is that correct, or maybe you have something else in your mind?
Yes. It's correct that we first we choose we build the model by the variant covariant structure that we propose. Like we use the unstructured, we will break the model by the unstructured variant covariant matrix in our model, and then we run the model, and then we get the fit indices. But if we get the more suitable matrix variant covariant, it will have effect that we will get the more accurately parameter estimate. Maybe we can. This is the p-value of the feeding effect. The p-value of the feeding effect from the simulation study, if we generate the data from the autoregressive heterogeneous first order autoregressive, and then we model the data by the R structure with heterogeneous autoregressive, we will have the p-value is 0.05. But if we structure and we build the model by the heterogeneous component symmetry, we will have greater p-value. We will have greater p-value. Since we know that every data is always best which model with unstructured, so we also model the heterogeneous first order autoregressive with unstructured variant covariant. We can see that the p-value of the true model, since we generate the data with heterogeneous autoregressive, and then we model the data with matrix variant covariant R structure also heterogeneous first order autoregressive, the p-value is more less than if we try to model with maybe wrong variant covariant structure. That's the advantage of the linear mixed model. If we can define the suitable matrix variant covariant structure, we will have accurate parameter estimate, more accurate.
Okay, next question. Maybe Bu Titi. Yeah.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the time, Miss Siti Maria. Actually, I'm not to understand what Miss Novi present, but I want to know any concern, any different model I ever know that I ever use panel data regression. I use panel data regression. I think this model use the same pattern with longitudinal data, but in panel data I can examine the effect of any variable to the, for example, in this case, children with data. Gitu. So I want to know is this model can do the same for the panel data that I ever used before. Thank you.
It's interesting question. I myself actually always ask with myself too that the panel data was different, the panel data analysis with the longitudinal data analysis. I and I already have a little answer for this question. Um, the variant covariance assumption, and from the panel data is not much as the linear mixed model. They only presume as the constant variant, seemingly unrelated, or or I think I only know that there's constant variant covariant, and then seemingly unrelated between the series. Yes, uh, that's the difference from the panel data analysis and the longitudinal analysis. Which the longitudinal analysis, especially in the linear mixed model, we can model the data more. Yes, the same individual. But in panel data, we not also we not also determine where's the covariate is being the fixed effect and then the random effects. I think it's the difference that the prism of the covariant matrix in panel and the model in the longitudinal data first, and then the second is in the panel data we not determine where the covariate is being fixed. But in linear model, we we determine the fixed covariate. Nanti di belakang aja.
I mean, can I know? Can I examine? For example, I have other variable, to examine the effect of other variable to the weight of children. Weight of children.
We can assess another data, such as the weight children data, fits model, and we have to define where the covariate being the fixed covariate, where we that we will analysis the effect and the fixed effect from the covariate, and then the random effect, and then we can I think it's not easy, right? Since we have more explanation, we have to have acknowledgement where with the coverage with treatable as a random, that are or the effects is need to analysis as a random, or the covariate is need to analysis to uh, as a fix. Uh, it's not easy as we say like this. Yes,
Is it possible?
possible. Is it possible?
Habis ini kita ngomongin. Betul ya, Mas Kim? Mas Kim udah bawa kertas, bawa paper. Ya, let's Pak Kim. Sini.
Hanya Pak Sukim.
Sini Mas Kim. Biar bikin. Udah di print slide-nya loh.
Udah lulus kelas.
Ayo betul. Mana Pak?
Ada on. Oni dulu Oni.
Ayo Pak.
Ini lagi bingung ini ngomong
Bahasa
apa.
Inggris dulu.
Dia udah nyala.
Dimaklumin lah.
Mixed language aja.
Oke. Mixed language nggak apa-apa. Iya, no problem. No problem. With bahasa saja, no problem.
After Java, then Pak Sukim will.
Oke.
Ya, Ramis ya, Pak Sukim ya. Kayak anak.
Kalau nggak sweet siapa duluan?
Ya, Bu Novi, first of all, congratulate with your achievement that I'm very proud of you that during
Live streaming soalnya.
during a very short
We need to record your voice.
during a very short time, if I'm mistaken, you just about 2 years for study in IPB, or less than 2 years. But your name is paper. Okay. But at least I'm still proud of you. Maybe all of us also proud about your achievement, this, especially Bu Titi as
My first come to the discussion. Sorry, Miss Titi Maria.
Actually, I want to ask about the benefit of using this model. Yeah, even though that you already explained about the difference this model with like ordinary regression linear model, but for me still unclear because I'm not much know about this. And second one, usually decision maker, for example, like Bupati, Gubernur, they do not care about what kind of model or what kind of method that we want to use for analyzing the data. So I want to know what's, for example, for the analyzing about the growth of the children, you just use simulation, right? But the property data, you also make a conclusion. Yeah, one conclusion that you mentioned that region currently is not have an effect for differentiating Western and Eastern and Western. For this conclusion, I a bit disagree. Yeah, why I have that opinion? Because when you use the property data, if I'm not mistaken, you use percentage of people, poor people. Yeah, you know how to measure the poverty data for the percentage of poor people that's come from the poverty line comparison to the poverty line for each region. I think be caution. I mean, be careful when you make a conclusion about that, because maybe that's because of you use this kind of poverty data, because there are other kind of poverty data. So I'm just curious when you suggest this conclusion to the, for example, like bupati or governor, yeah, how they react about this, because we have to be careful when we suggest or recommend something based on our research. For example, this is my knowledge. For example, last week, Robert, Pak Sukim, Pak Suki and I went to BNPB, and we watched a film that scientists teach people or communities based on their result of their research. But in fact, the result is not true for that situation. It's very danger for that. So I also, what do you think about your conclusion in this case? I think that's all to make Pak Sukim want to speak after me. Thank you.
Okay. Next, Pak Sukim.
Ya, pertama benefitnya, kedua kesimpulannya tadi.
Ya, ayo masukin. Nanti nggak boleh masuk ruangan. Nanti dikunciin loh ruangannya. Oh iya, di Inggris.
Ulang pertanyaan nggak, Pak?
Nggak apa-apa.
Monggo, Pak.
Oke.
Slide.
Iya, kan belum masuk.
Yang tak mukanya apa soalnya?
Yang penting kuenya.
Ayo, please, masukin.
Itu kan tadi.
Please give a big applause to Pak
Thank you for Chan. Maybe my question repeat. In the linear model, how to select the best model and diagnose how will a model is fit.
Thank you for the question from Mrs. Teo and Pak Sukim. From the first question,
Benefit.
the advantage of the linear mixed model first is we can we can propose some covariant structure rather than the variant covariant structure that we use in the ordinary least square. That in ordinary least square, we always presume that the variant covariant is have zero expectation, and constant variance. But in linear mixed model, we can model the variant covariant more suitable to the data first. And the second advantage is if we can model the variant covariant structures is correctly, we will have accurately or more accurately variant covariant estimate. This is the advantage, and the third advantage that in the longitudinal data analysis we can uh, use this model into the we call that unbalanced data, that we can the data is not in the same point in the same point, and then we also have a little point data, not longer as the time series data. We also can build with this model. And the second question is how we try to explain this conclusion to the stakeholders like the government. In our result, we not um, we not we not honestly tell that the region not do not have effect in eradicating poverty. We just say that from the model, there are so many model that we can use. Uh, which one we use is up to you. That's in our conclusion. Since like we just and we also state that we use the in our paper we also state the data is the we have percentage poverty for each province. I mean it's just an clearly state that we use the proportion of the poor people, and in the conclusion we we not uh, uh, explain clearly explain clearly that the region do not affect the model. We just say that there are many model with not constantly variance covariant assume that you can use.
Maybe if I can suggest, if you still, I mean, if I can call it as afraid to telling the truth, maybe you can say that this
Itu emang nggak dibahas.
Ya makanya saya juga
uh,
tanyain.
is not, is not supported by other fact, finding other research, for example. And you can say maybe it because, for example, we measure the property or how you use property data in this data.
Thank you, Budil, for the advice. Maybe I will note it that to the next research. Thanks. And the question from the Pak Sukim is
Select the best model.
how the select
How to select the best model and diagnose how well.
okay. Maybe I will try to give more explanation, little more explanation in the simulation study. To have a conclusion, the best model, we first of all we generate the data from the from the fifth from the five variant covariance structure. We generate the data, and the data is we replicate it for 1000 times, and then from the 1000 time we model the data by also fifth the variant covariance structure, and from the fifth replication we use the three fit indices criteria which I tell before that we use the mean to log likelihood, uh, AKK information criteria, Bayesian information criteria, to know which one have the best fit model. And from 10 replication, we rank the model which have the best fit uh, with three indices criteria. And then by the rank, we rank the best fit in the little value, and then the worst fit in the greater value. And by the rank, we know that the AR1 heterogeneous first order autoregressive is not the best, but the can be alternative. Since the best model is always unstructured. Why? Because in the unstructured variant covariant, they have a unique parameter. They have a unique value in its variant covariant cell. So the best variant covariant matrix is always unstructured, but it have unique value in single cell in every variant covariant matrix. It's too hard, difficult to explain. We think. Then we have more. Uh, we have if we have a little parameter, I think we have efficient estimation, and we have a simple explanation. So what we have in this paper is not the best fit, but it's the uh, uh, better, but it can be alternative.
Thank you. Thank you. Thank you.
Thank you, Mbak Sukim.
Cantika. Is there any questions? Maybe from Patas? Enough. Okay. Oh yeah. Actually, Pastia is listening to our discussion, and he gives greetings for us here. And I have one deposit question. Actually, two, but the second question is already answered. So the question is how to test for fixed effect and the best covariance structure. Already answered, right?
Fixed effect.
How to test for fixed effect and the best covariance structure.
The best covariance structure is test with the three fit indices criteria that I told before. It tests with the fit indices like BIC, and then the fixed effect. Fixed effect we uh, test like we use the caseware,
Okay, square.
and we just show the p-value of the parameter estimate value in the slide uh, 20 second slide. 20-second slide, we show the value of the parameter estimate, and we also show the p-value of the parameter estimate. This is in the 20 second. By each structure variant covariant matrix, such as in first line, we have the parameter estimate of region is 1.5, but the p-value is 2.0. If we model the variant covariant with unstructured covariant matrix.
Okay. Yeah. Thank you for the answer. Is there any question maybe from Rina, maybe Mbak Oni or Mbak lupa gue namanya. Mbak Winnie, ya.
Sabar ya. Sabar. Sabar.
I'm sorry. Mau tanya lagi? Ya, oke. I think because yeah.
From that side,
Question, yeah.
at
At least one question, please.
Maybe you have to move here.
Yeah. This is not fair. Say good to you. Yeah, please. Maybe Mbak Winnie want to ask one question. Lanjut, ayo. We wait you. Mbak nanya Mbak. Ayo. Mbak Winnie mau nanya.
Dina ayo, nanya SPJ ya.
Narasumber ini
Yeah. Let's please, Mbak Winnie. Yeah, please use the mic. Yeah.
one from Winnie, second from the baby.
Thank you. Maybe one question. Mbak Novi, talk about rank, apa sih tadi rank, how we rank the best structure.
Thank you for the question. We rank the best variant covariant structure is suitable from the fit indices. Like if we use the AIC or BIC, we use the less value is the best fit like this. And if they have the less value in AIC, the model is more fit than the others. If and then we value we rank with the little value, and then if the model have the larger AIC, we rank it in the bigger value. Maybe I show in the board that if we generate the data with autoregressive first order as the variant covariant, and then we model the data with the variant covariant with first autoregressive or heterogeneous autoregressive, there is the fit indices value. From this, we show in the minus 2 log likelihood, if we generate the data by first order autoregressive, the less value is unstructured variant covariant. So the unstructured model is the first best model. It's the first best model, and the second model is uh, uh, heterogeneous autoregressive. So there is a top of three model. There is top of three model from the fit indices minus 2 log likelihood. If we generate the data from the first order autoregressive, and then if we rank by the other fit indices like AIC, it also the top of three, like first autoregressive, heterogeneous first order autoregressive, unstructured, is also have the less value. So it's the best top of three. And then we use like this in under variant structure. Then we compile. In this compilation, we know that For every generated data, the unstructured by the minus log likelihood is always the best model. But we know that unstructured is not efficient in parameter estimation. But in PIC and AIC, uh, the fact data, the generate fact data is best if we model with the variant covariant the same as the generate. This is the rank. This is the rank. And uh, after we rank, we sum. We sum the rank, like the uh, component symmetry, what the value if we rank from the 5 generate data. Uh, and the conclusion is in the first side. This is the sum of the rank. This is the sum of the rank that unstructured with the minus 2 log likelihood if have uh, 3 value. The value is 3. I mean, it's very less, and then it's the best model. But we not choose the unstructured, and then so we not say that we will build the best variant covariant, but we say it's an alternative since the best is always unstructured.
Okay. Thank you for Mbak Winnie for the questions. And maybe this is the last questions for me. It doesn't relate to the topic, but I think I'm very proud of you because you can uh, you can apa ya make a paper in procedural severe science direct. I think it's a very amazing for me. I think I just curious how long did you conduct this research?
Alhamdulillah, I'm accompanied by amazing people like all of you. I mean, thank you. We 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 write or we work from this paper in maybe in one semester or in 6 months, and and in that 6 months, uh, we work not too hard,
Wow,
but so hard. Not too hard, but so hard. I'm not. I think that all of you will have more uh, uh, achievement more than me. More. I mean,
Yeah. Okay, so you start from the original paper, then conduct the research and focus on one topic, then break into two papers. Okay. Okay, I think that's all because there is no questions again. Uh, Please give a big applause for Bu Novi. I think actually uh, normally in our monthly research education discussion we have two presenter, but now I think this is amazing because one presenter can full can fulfill the time until 3 p.m. Luar biasa, amazing. Thank you for the detailed explanation about linear mixed model and hierarchical linear mixed model for poverty. I think this is a very interesting topic, although I don't understand and confusing. And for our audience here, thank you very much for your attendance. I have a big hope that in the next month you will come again to our event and with the another presenter with another topic, I think. Thank you very much for all of you and wish we luck. I mean, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Ya, bahasa Indonesia. Stop. Nah, ini bisa.